Solving systems by substitution. A system means more than one linear equation. Linear means that this equation will create a line on a graph, and this will also create a straight line on the graph. Now, when we solve, or when we finally find the answer, what we're finding, good heavens, that's not a way to start. If I graphed this first equation, and it might be like that, possibly. And the other equation, maybe when I do it, it's graphed like this. That is a system because there's two lines. Two equations make two lines, and the solution is the point where they cross. That's what we're finding when we solve a system. So our solution will have to have two values. It'll have to have an x value and a y value. So remember, when we're solving these by substitution or by graphing or whatever, we are going to have two answers, an x answer and a y answer. Okay? So this is a short little lesson on what systems are, more than one equation on the same graph, and the solution is the place where they cross. The place where they cross is the address or the coordinates of this particular point. So we know we're going to have an x value when we're done, and we will have a y value when we're finished. So here's number one. Now, substitution means we are going to take something and substitute it into the other equation. Okay, we're going to take some value out of one of the equations and take it and substitute it into the other equations. Okay, that's what we're talking about when we talk about substitution. So the way that you work these problems is we're going to look at both of the equations, and we're going to make this the easiest. We're going to look for the one that already has a variable solved for, which means we're really close here. This is a 1x. So all I have to do is take this equation, move this 8y over here, then I will know what x is equal to. So that's what we're going to do. This is the easiest one, so we're going to solve this for x. So I have x plus 8y equals 26. If I want to solve for x, I'm going to subtract the 8y, subtract the 8y. And so I have that x is equal to 26 minus 8y. Okay? Now that isn't our final answer, but this is what x is equal to right now. This means this is what I'm going to substitute into the other equation. Now I'm going to, yes? Okay. A request to go slower. So I'm going to erase and make myself some more room.
Why do you subtract 8y from both sides?
From the first one? Because this one, I was just going to choose which one would be easier to solve for. And I said, ooh, that one's already by itself. I think I'm going to solve this one. You could choose. You can even choose if one of them was almost solved for y, you can use that one. We'll do another one after this, okay? So I chose this because it was easy, okay? Now, that's just the first part, because what I've done is I figured out what I want to substitute. This has the same value as x, and I got it out of this equation. So I'm going to plug this in or substitute it in to the other equation. Stay with it, okay? Substitution is probably more difficult to understand than the other methods. So I'm going to copy this other equation And every time I come to an X, I'm going to put this in. I'll tell you why here in a minute. So every time I come to an X, I'm going to put what the X is equal to. Make sure you can see it.
Wait, I'm confused. Why did you
Just a minute. I'm going to answer your question. Just making sure they can see it all. Okay, question?
why did you put, okay, it's 1x, so why did you put the 26 minus 8y? Whatever it is.
I'm glad you asked because that's my next thing. Now, the reason that we substituted, and we had that question right here in class, the reason that we substituted is because if we have an equation that has two variables in it, we can't find an answer for one of the variables. So what we're going to do is we are manipulating this so that all I have now in the equation are just y's. And when I have just y's, now I can get y by itself and find out exactly what the answer to y is. So we're going to do the math here. We know we have to get rid of parentheses first, and since I can't work this inside, I'm going to use my distributive property. 5 times 26 is 130, I think. Those of you at home, if it's wrong, tell me. 40y, because I did 5 times 8 is 40y. It was right, okay. Plus 2y equals 16. Okay, I want to solve for y. There's too many of them, but I'm not going to have to get rid of one of them because they're both on the same side. So what is negative 40 plus 2?
Wait, negative 40? Oh, okay.
Is it negative 38? Did you do it? Negative 40 plus 2, because both of these are y's, I can put them together and get negative 38y, right? Okay. And if I want to solve for y, I need to get rid of this 130. Subtract 130. This is just math now. Solving equations. So now I have a negative 38y equals negative 114. Is that correct?
Did you do 16 minus 130?
Yes. Is that correct?
I was confused myself. Why?
16 minus 130, negative 114. And now if I want to solve for the y, here I am, and I want to divide by negative 38 and divide by negative 38. So I find out that y is equal to 3. Okay? Because this had only y's in it. So since I'm running out of room, remember that the solution is where the two lines cross. I'll put this where you can see. Again, a reminder that the solution is the place where the two lines cross. So my answer will have an x and a y value, right? So I just got the y value.
Wait, where did you subtracted 38 from 144 and then cut it out, right?
No, I divided. This is divided.
Oh.
Okay.
Why did you divide it when you subtracted it?
Because this is multiply right here.
Mhm.
And I have to do the opposite of multiply. So I have to divide by what I want to get rid of. And if I did it on this side, it has to be done on this side. Okay, I have to follow suit and do the same thing.
What if there's a remainder?
Then it will be a decimal or a fraction, and you can do that. It can be a decimal or fraction. Good questions. Now, I hope you have this because as I was saying, we have the y value, we still need the x value. And since I'm running out of room, I'm going to get rid of this. Bless you. Okay, I have the y value. I know that y is 3. So I can substitute 3 in for y anywhere I see it. And looky here. I already have an equation that says x equals. All I have to do is substitute 3 for the y that I already found. So I have 26 minus 8 times 3. X is equal to 26 minus 24, which is equal to 2. X is equal to 2. So the x value of the intersection point is 2. I know it's the first time. Are you okay for now, Mary? Doris?
Yes, yes, I'm fine.
Yes, I'm fine.
Okay, I heard Doris. Mary?
Yes, I'm okay. Thank you.
So far, we'll do another one. Let's look at, okay, I'll do one more on the front page and then we'll pick one off of the next 2 pages for you. All of these are going to be done with the substitution method. So let me pick one and let's work this one. How about let's do number 5. Number 5. This is still on page 4 of your worksheet. And number 5 is right here. Okay, number 5. So I have negative 5 equals 2m plus 6m. This will make one line on the graph. This pretend that this is the x and the y. Same thing. 4m plus 5m minus 18 equals 0. Now, sometimes you'll see a system with the bracket. It doesn't have to have the bracket to be a system. They will tell you in the instructions if it's a system. But if you see the brackets, that means the same thing. All right, so using the substitution method, we said we will need to go to one of these equations, find the easiest one, something that is almost solved for already. And you'll notice already in this problem that neither one of them have anything solved for. So you can pick whatever you want. I think I don't think it matters. I'm going to choose the top one. You can choose whichever one you want to start out with. Always choose the easy one if you can see an easy one. And then, because neither one of these is almost solved for, I'm just going to choose something. So I want to solve for the m to start out with. That's what I decided I want to do. So if I want to solve for the m, then I will have to subtract 6m and subtract 6m. Again, this is simply solving equations. So if you're still having trouble with that, Please go back and find the YouTube lesson for this. So now this becomes 0, this 2m equals negative 6m minus 5. Okay, I'm still trying to solve for m because that's what I decided to do. And so I'm going to have to divide by 2 because this is multiplying. I'm going to have to divide by 2 on this side, which means I have to divide the whole side here. I like to separate them so I don't forget to divide somewhere. So now I have m equals. Uh-huh.
I remember whenever you start dividing apparently I asked you why you wouldn't do the number when you always was doing the 2 on the ends.
Right here.
Dividing them, but why are you dividing that one?
But most people teach this. And that's a good question. 6m, I'm going to write this again, minus 5 equals 2m. Most teachers teach it that if I'm going to divide by 2 here, I divide this whole side by 2. Okay, this is what we're actually doing. But sometimes students will divide this one and then they forget to divide this one. So I just decided to split it up and try to remind myself it's going to have to be 2 on both of them. Do you see? A lot of the instructors simply just say, divide both sides by 2. So that was a really good question. Okay, bears repeating. Okay, so when I divide this side, I'm still left with an m. Negative 6 divided by 2 is negative 3. Uh-oh, that's an m. Ooh, Deborah. Okay, negative 3n minus 5/2. Now, I know fractions scare you, but you're going to have to be brave. Now, m is equal to this stuff, which means I'm going to go into the other equation, not the one that I just solved. I solved the first one, so I'm going to plug in or substitute into the second one. So I'm going to take the second equation, write it down just like it is, except when I come to the m, I'm going to substitute this information in here. Substitution. So 4, but here's an m, and m is equal to that stuff. Plus 5n minus 18 equals 0. Okay, if you notice, the whole reason that we substitute is so that we'll have only one variable. We only have n's in here. This is the only way that we can solve this. Simple math, solving equations now. First thing we have to do is get rid of the parentheses. So we use the distributive property here. Negative 12n minus 10. If you take 4 times this fraction, you will get 10 plus 5n minus 18 equals 0. Now, if you look on this side, you can add 18, and then you can add 10, and then blah, 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 blah. But since all of this stuff is on the same side, why don't we just get the n's together and the plain numbers or constants together? It'll be easier to solve. So I'm going to put negative 12n and a positive 5n. What do you get? Negative 12 plus 5. You'll get a negative 7n's.
Wait.
Okay, what I
So
did,
you added the 2 with the variables, and then you added 10 and 18.
the 2 constants, because they're all on the same side. I don't have to get rid of anything. I'm just going to put those together so it makes it look a little bit easier to work. Okay? So that's all I did is gather my common terms. Yes, good. I like that. Now I want to solve for the n. And so I'm going to have to get rid of the 28. Add 28 to both sides. And so now I have negative 7n equals 28. One more step. I want to solve for n. So I'm going to have to divide because these are multiplied. When they're crammed together, they're multiplied. Divide by negative 7. Divide by negative 7. So n is equal to negative 4. Are we okay?
Yeah, it's dividing.
Yes, yes. So part of our solution, we're going to put one of our answers here. Now, they didn't X and Y, so where do these things go? Okay, if they're using different letters for the variables, then the rule that I stick to, and it's worked, is I have M and N. So alphabetical order, which one comes first? The M comes first, right? And so I put the M first. I do alphabetical order. Just like the X and Y are in alphabetical order, okay? So M and N are going to be in our answer. So we just found the N is a negative 4. So immediately I'm going to write it here so I don't lose it in all of this mess, okay? Now I have to find the M, but usually that's pretty easy because the equation that we solved for says M equals. So all I have to do is plug this in and then do the math. Okay, so I'm going to say negative 3 times negative 7, because negative 3 here, negative 7 is in, minus 5 halves is going to be equal to n. So all I have to do is use my calculator. Negative 3 times negative 7 is 21, minus 5 halves equals the value of m. So if you use your calculator, 2 minus 5. So m is going to equal, hopefully, 37 over 2. I'm hoping so.
The 21 minus
5 halves. 21 minus this fraction. 37 halves,
Yeah.
or 18.5 if you change it, use your toggle switch and change it to a decimal. I was going to see what they put for an answer, whether they do decimals or fractions. You need to be able to do both. So negative 4, 19 halves. I never screwed up somewhere. Said 19 halves, so that's like half of that. Okay, let's make sure. Did y'all see any mistakes I made? Okay, checking if I wrote it down correctly. The negative 4, they said is correct. So my problem is when I plug the back in. Let's look and see. This is my equation here. And this is where I plugged in. This became negative 3n minus 5 halves equals n. So negative 3, oh, good heavens. What is n? It's a negative 4, not a negative 7. Good heavens. You got to plug in the right value. This is n equals a negative 4. Negative 4. Gotta watch out for me. Okay, so now I have negative times negative is positive 12. Now I'm going to try this again. M is equal to 12 minus 5 halves. So that's going to be 19 halves. Is that correct? Or 9.5 if you, all you have to do is use the toggle switch on your calculator to get a decimal. If that's what's in the multiple choice answers in the GED test, then if you're getting a fraction answer, but all they give is decimals, use your toggle switch and it'll give you your decimal. Same backwards and forwards. If you're getting a decimal, but they have fractions, use your toggle switch and it'll do it. It is this one, right above the equals. So don't, there. No. Oh, okay. Just go ahead and do this again. Do the 12 minus 5 halves. And scoot over and press enter. And that gives you the fraction. But what if you want a decimal? You push this toggle switch right here. See it? Now push it again. It goes back. It goes back and forth, okay? So it'll change it for you. So then we have 19 halves here. Just be careful about what you plug in. I don't know where I got, got the -7 right there. Silly girl. And remember, if they use different letters than the X and Y, just put the first one and the second one in an alphabetical order, and that will give you the right answer. There's Miss Sherry. Gotcha. We're waiting for Sherry to come in. I'm going to go to like these two that we just did the examples on came from page 4. Now I'm going to go pick one off of page 5 and make sure that there's nothing that will be surprising you. Page 5. Hi, Sherry.
Good morning.
You'll definitely want to see the first part of the YouTube, okay?
Okay.
Now we are in the systems of equation substitution method. There are 3 pages of this, page 4, 5, and 6. We have done 2 examples off of page 4. I'm going to page 5 now. Okay. So the best places to start is number 1. This is the problem we're going to do now. It says solve each system of equations using the substitution method. Now also, Sherry,
Yes,
I
ma'am.
that on Friday we learned how to solve systems by graphing. So that was page 1, 2, and 3 of the worksheet. And today is substitution. Tomorrow will be the addition or elimination method. Number 1. This is on page 5. So this will be the first time you're seeing it, Sherry. And don't get too upset. It takes a little time to see it. This is a system because it represents 2 graphed lines on the same graph. And the solution is where they cross. But today we're not even graphing these. We're finding it algebraically by using the substitution method. Now our answer are the coordinates of where the 2 lines cross. And instead of X and Y, I'm using UV. So which one goes first? Come on. Come on, guys.
4 and 5,
Well, I need the letters. The letters.
X.
We don't have X. In
Oh,
our particular problem here, we have U's and V's.
oh,
So here, just a minute ago, I told everybody watching which one we'll use first. Which letter goes here and which letter goes here? Come on.
U.
Alphabetical order. Oh, I think I heard Doris.
U and then V.
The U and then the V. We always know it's X and Y, but if they're not using X and Y in the problem, then we put these letters in alphabetical order. Everybody good? So here's how we've been working this. What we decided is you can choose either equation and you can choose either variable to start with. Obviously, neither one of these are even close to being solved for a variable, so you can choose whatever you want. In the last problem, we chose the first one. Let's choose the second one today, okay? So I'm going to say 2v plus 9u equals 63. And in starting this problem, you can even choose which variable you want to solve for. I think I want to solve for v. Okay, which means that I have to subtract 9u from both sides. See, the first part, you can choose what you want. You can choose either equation and you can choose either variable. This will all work. And so now I have 2v's equals 63 minus 9u. And to get v by itself, I need to divide by 2. So I divide the whole side by 2, but I separate it so I remember to do it all. V equals 63 over 2 minus 9 halves u. When you get all excited and nervous because it's all you have a calculator and you can use that calculator on the test. So what I found out is the value of v is the same as this. So this is where my substitution happens. I solved this equation, so I have to substitute this value into the other equation. Here's where the substitution happens. Since I solved this one, I'm going to write this one down, and when I come to a v, I'm going to plug in what v is equal to. So here we go. 4u plus 5. Here's a v, so I'm going to put this stuff in here. 63 over 2 minus 9 halves u equals 28. Make sure it's all on the screen. There we go. Now, the reason for this, we explained just a little while ago, is because I can't solve this and get an actual answer because it has 2 variables in it. That's why I had to do this. But the substitution allowed me an equation that now only has u's in it. Now I can solve and find out an actual number answer that u is equal to. So here we go. I'm going to multiply this out first because that is our parentheses. So now I have 15, 3/15 halves. Ugh. Minus 45 halves u. Use your calculator. 5 times 63 is 315 over 2 minus 5 times 9 is 45 over 2 u equals 28. Okay, here's my u. Stay focused on what you're trying to solve for. So you're going to subtract this fraction. And subtract here. Whoa. Okay. So I have negative 45. Did I get it wrong? I'm hearing somebody talk to me. Did you have something to say? Okay.
Miss Bond,
Yes.
why did you leave the for you?
Thank you. Thank you. Oversight again. Thank you. For you plus. Is that better? You guys have to watch me. For you. Okay. So we've got two things we need to do. Here are two u's that we can get our common terms together. So 8 minus 45, negative 37 over 2 u's. Use your calculator. Take 4 minus 45 over 2, because both of these are u's. You can put those together. So make sure that I did this correctly, please. 4 minus 45. 8.
4 minus 45 is negative 41.
No. This, it's a plain 4 and a fraction 45 over 2.
So you want 4 minus 45 over 2.
So negative 37 over 2?
Negative 37.
Should be.
It is.
Okay, thank you. And on this side, please do that. So I have 259 negative over 2, still ugly. Still totally ugly. Are you guys with me? It's all fractions, but I don't want you to get dizzy and stop. You have a calculator. All we did on this side, these u's were on the same side, so I put them together. 4 minus this fraction gave me this many u's. On this side, I did the number 28 minus 315 halves, which just give it to the calculator. And so to get rid of this, I'm going to multiply by the reciprocal. 2 over 37 negative, and over here, negative 2 over 37. Cancel, cancel, and cancel the negatives. So I have u equals. Negative 259, because this, and this, and this cancel. So I have 259 divided by 37 equals. And see, I was very patient, and it came out 7. U equals 7. So I put 7 in U's place, and when I do that, I notice that I still need the value for V. But V gets very easy now. Because this V is already solved for, so I'm going to use this equation right here that I worked out earlier, and I'm going to plug in 7 for the U. So now I have V equals 63 over 2 minus 9 over 2 times 7 over 1, because u is 7. Believe it or not, this is crazy. I have 63 over 2 minus 9 times 7. Guess what that is? 63 over 2. So v, after all of that, is equal to 0. And so the place where these two graphed lines intersect is the point 70. There are just several steps. Let's go over those again. When you see two equations, you're going to solve one of these for one of the variables. Your choice. No matter what you choose, if you do the math, they will come out correct. If you choose one of them and your friend next to you chooses another one, you will still get the same answer. So the first thing you do is choose and then solve one of these equations for one of the variables. You take what that variable is equal to and plug it into the other equation. If this is v, then you put that stuff in where v is. That's what we did here. And solve for the only variable that is in there. One more step, plug it back in to this where we solved. It's a process. Go back and look at your notes over and over again about how to do this. Okay, probably the biggest problem that students have with this is they will solve here, they will plug it in like they're supposed to, and when they get 7, they think they're finished. That's why I go ahead and write the parentheses and the comma here and write both my variables at the very beginning, so that when I put this answer in here, I realize I still have to do something else. It's a lot to take in. I will be posting the video, the YouTube video, as soon as we're finished here. Feel free to go over these and over these and over these. This is substitution. I do have good news. The substitution method is what I think is the hardest for students. Tomorrow, the addition method is my absolute favorite. So I am expecting you to like it the best too, but you need to know the substitution method. So we'll spend today working on pages 4, 5, and 6 in your systems packet. I will stay on as long as you want on the Zoom. Feel free to ask questions. If you get off and then you have questions, feel free to text me a picture of the problem and the work you've done, and I will help you find where you need to. I'll answer your questions. Okay, I'll answer questions, and if I have to, I'll send one of them finished for you so you can follow the method. But that's all I have for today. Do pages 1 through 6 now. 1, 2, 3 is on graphing. 4, 5, 6 is on substitution. The last 3 are on the elimination method, which I'm telling you, I like it the best. It doesn't fill up quite as much room on the chalkboard. And then the last page, the page 10, tells you to look at the problem and decide which way you want to do it. Do you want to graph? Do you want to do substitution? Or do you want to do addition? And we'll talk about that one too. Any questions?